Hello, my name is Knapp, and this is Anthony Sylvester, and today we'll be talking to you about our senior project, which involved creating a color sorting VEX robot.
It is predicted that the increase in intelligent robotics will mostly be in consumer robotics. The predicted compound annual growth rate for consumer robotics is 17.4%. This is because the low cost of microprocessors allows for companies to develop and manufacture a wider range of consumer robotics ranging from cleaning robots to personal assistants. Some real-life applications that we came across during our demonstration were a TSA luggage sorter and a machine that places color-sorted toothpaste caps on corresponding toothpaste bottles.
So our objective for creating this robot involved creating a robot that had a manual start button, having a robot that can move parts automatically with a conveyor belt, having a color and distance sensor to see when the blocks were on the conveyor belt and have it go into the next loop of moving and placing the blocks in the designated color bins.
In order to do this, we purchased the VEX Robotics Super Kit as well as a bunch of different VEX Robotics add-ons. We can get into that more during our robot presentation.
So during our design phase, we were able to successfully purchase and test the VEX Robotics Kit, and we found it was the best design for us. And then we constructed the basic machine of it, which involved just basic testing, seeing if the motors worked and the color sensors worked. We tried alternate designs and realized that our original design was the best idea for us. And then when we found that that was the best design, we moved on to the further testing phases and building the actual design itself.
During our testing phase, we wanted to test the hardware and software, as well as make adjustments and redesign and retest as necessary.
So, as a result, we'll show you in a second exactly how the robot works, but it works nearly 100% of the time. The only issue we ever have is sometimes the Legos themselves will bounce out of the bins. That's not really something that we can fix with our design. And we figured it's negligible enough to where we can consider the project a success. So, two major things that we learned. One, definitely time management. This project spanned well over 6 months between both semesters, and Anthony and I had to work together to make our schedules meet and get this robot done in the allotted time frame. And the other big thing that we learned was troubleshooting. We had to troubleshoot software, hardware throughout the design phase, and a lot of the last chunk of this semester was purely troubleshooting to get near that 100% success rate.
So here's our Gantt chart that just kind of shows you that what time frame we had to do to create our robot, have it done and done with. And we actually met our Gantt chart ahead of schedule, so that was pretty good because it allowed us to go back and really look at our project and retest it if necessary, or find upgrades and how to improve it.
So now we will show you a flow chart along with exactly what the robot is doing when it's going through each process of the flow chart, and show you how the robot works. So we begin by loading the program into the processor of the robot by pressing the check mark twice. The arm initializes, gets all the motors ready, and then the conveyor belt begins to turn until it loads the orange block onto the belt. It's immediately detected by the distance sensor, which sends the robot into the rest of the loop. The color sensor senses that it's orange, displays it, and then sets the proper angle for the arm to drop it into the correct bin. The arm releases the block and then resets to its initial starting point. Once again, the conveyor belt starts until the pegs pull a new block on. It's detected by the distance sensor. Color sensor senses that it's yellow and puts it into the loop of the arm, picking up and turning to the proper angle, and then releasing the yellow brick.
In conclusion, we have discussed why robotics and automation are becoming a fundamental aspect of society and why the demand for them is so high. We have also discussed what we hope for our machines to be able to accomplish and how this project can be compared to similar machines on the grander scheme, such as the TSA luggage sorter or the color sorting bottle cap for the toothpaste. Just for recap, our machine has a manual start button, and then it automatically sorts parts based on their color into designated color bins. We also have a touch LED that indicates which color part is being sorted. Thank you for watching our presentation.